Okay, we stopped here last time. We were talking about the welding, and we said there are two types of the welding: vision welding and solid state welding. I hope you remember vision welding, which is a liquid state welding; solid state welding, which mean no liquid at all, means solid. We do solid welding. Last time we start talking about the vision welding. We discussed last time about the vision welding and said that vision welding we melt the two substrate. I mean, in a welding zone, definitely in a welding zone, we melt the two substrate in a welding zone. And we usually in vision welding or liquid state welding, right? We melt the material in a welding zone, post material. And this one, I remind you, this one limited to similar material, to welding similar material. Please remember that all time. This limited to welding similar material, and we usually, in a vision welding, we usually use a filler material. This filler is must be compatible actually. This filler material that we use, this is a filler. When we heat, filler will melt and deposit it in a welding zone, and this one compatible with the base material. And the functionality of this one is to compensate the material evaporated during the welding process and also to provide the bulk to the welding and so on. So this is a weld done here in vision welding. And as I told you last time, some cases in a vision welding, we don't add it filler material, we call it autogeneous. And this one I will describe later. I will show you some example of vision welding that we are not adding filler material. And in this case, if the vision welding, we don't add filler material, we call autogeneous weld. And also, we said that last time I talk about the vision welding. We have arc welding, we have resistance welding, oxyfoil gas welding, and electron beam welding and laser welding. This is a type of some example of vision welding. And as I told you also last time, if you remember that this different method is different heating method. So for example, here you're heating by arc welding, you're heating by resistance welding, by oxyfoil gas welding, and you're heating by using electron beam or laser beam welding. That's what we were discussing last time. And also, this is a basic fundamental of the vision welding that yes, this is a two substrate, and then you do the welding process. This is a filler, you drop filler material, finally you get well done, and this is a weld joint between the two base material. Finally, after the welding, both become one material. And I discussed also with you about the this one, which is here. You can see this is the weld. So this is a kind of arc welding as an example of vision welding. Arc welding is located here to join these two part or two material together. This is what we were discussing last time, and this is the hazard coming from the vision welding, which is the ultraviolet and smoke. And we can deal with this case by using helmet and using duct to remove the gas smoke. We stopped here last time about the solid state welding. The other type of the welding, which is a solid state welding, and I told you also, if you remember, solid state welding means there are no melting. We are not melting the substrate material. We are not melting We may heat material, but we are not melting. So temperature, even if you added temperature, must be below, must no melting below melting point. Must be, even if you added heat. So the idea here, we apply pressure, we apply pressure. When we apply pressure, material become very close to each other. When we apply pressure, as you can see, this is the material one, material two. When you apply pressure, when you apply force, material become close, very close to each other. If you look under microscope, you find like this. Even you can see it is perfectly matched, but still, if you look to the under microscope, you can find some gap. But with the time, material will diffuse. You can see that material will diffuse. Elemental migration happen between the two parts here. So some element move from up to down, and some other material move from down to up. Then diffusion happen. We call it diffusion welding also. Diffusion welding, because material element will migrate from up down and down up, then material will migrate with the time. With the time, you can see that bond will be created because exchange happen between the elements, the bond will be created, and finally you get well done. This is whatever we call is a solid state welding. And solid state welding is not limited to similar material. So you can weld in the solid state welding actually. In a solid state welding you can weld this similar material. يعني بالعربي احنا ممكن نعمل لحام مواد مختلفة باستخدام الديفيوجن welding او solid state welding. ليه؟ We don't have any problem with the heating and melting and contraction. Even if we add heat here, it is low temperature, usually lower than melting temperature, and should be fine. We just encourage the atom to move up and down and so on, then bond will be created and well will be done. Okay, let me show you a nice video about the solid state welding. Right, so here this is the video. Let me just bring it back. Diffusion bond or diffusion welding. Okay, this is a layer we put all layer together. We would like to weld this layer, then we put many layer here together. I apply pressure. Then if you look under microscope, you can see like this. This is the situation actually. When you leave it to the time, bond will be created. Atomic migration happen. Atomic migration happen and then bond will be created. After a while, material become, as you can see here, solid and well done. Then later, you try to see it become one part. All these parts become one part. If you cut here, you see material weld. It take time actually. It take time for this one to happen. It take time. So what they doing actually? It take time. So what they doing? Because it take time. Because it take time. They heating this material because it take time for weld to happen. They heating this material. Why heating material? To encourage atom to quickly move up and down. Then bond will create in a faster way, right? Okay, let me go back to the slide. So this what we call is the diffusion bonding. So diffusion bonding, as you said, that material will migrate up and down. Then finally you can just material get material. So solid state, and we call it also diffusion state welding. Okay, another example we call it friction welding. Friction welding is one example. Friction welding is one example in a solid state welding when we heating a material by friction. We apply friction to heat the material, so we allow material to migrate from one to other. So this is two parts. For example, this is a rotating shaft. This is a stationary shaft. We need to weld these two materials together. We would like to weld these two material together. This is a rotating shaft. This is not rotating. Then when you apply pressure, this one rotating, then friction happen here. Friction happen here in between. Due to the friction, temperature increase. Because we are applying pressure and friction here increasing the temperature, weld will happen between them. Migration quickly migrate atom, and finally bond will be created and you get well done here, as you can see here in a photo. Let me show you another video for this one, for this case, exactly for this case. Okay, right. Okay, here I stop the video. Here, this one is rotating. You will realize that this one is rotating, this one is not rotating. We need to have a relative motion between these two parts, so friction will increase the temperature. The functionality of the friction is to only increase the temperature because we need to heat the material. We can do without heat, we can just apply pressure, weld well done, but it takes time. So the issue is we heating this material to encourage the atom to quickly move right? To quickly move, to not take time, become shorter. Then you see that this one is rotating. Can you realize that this one is rotating? This one not rotating. Then friction will happen. You apply pressure now. You apply pressure. You apply pressure. Then you see that heat. Then heat will happen. Temperature here increase, but no melting. Temperature increase, but no melting. We're not melting the material. Then atom migrate quickly, atom migrate, and bond is created between the two material. And now stop. Now stop. Then no motion now, no relative motion now. Allow, we stop to allow material to migrate quickly and create a bond. Bond is created actually. Finish. Weld already done. These two material welded together become only one material. And then we need to cut this extra material. They're going to cut now they are both rotating together because they become one part. They removed the extra material. They remove the extra. You see that become one part. These two material become welded together and become one part, as you can see. So this is a example of solid state welding. Okay, let me go back to slide again. Then actually this is solid state welding. As I told you, this one is rotating. This one is rotating. I mean, this shaft is rotating. This shaft is not rotating. When you apply pressure, heat will be generated here. As you can see here, this is actual photo. Heat generated here and material becomes soft and atom will migrate and bond will be created. You stop rotation, then you allow welding done, then it's finished. Also here, this one we call it is stir welding, friction stir welding. Friction stir welding, we would like to weld these two material, these two plates together, and this a rotating shaft is rotating tool. We call it rotating tool is just to help to heat the two material. So this one rotating here and moving. It is rotating and moving. So when it is rotating, it heats the area here. It heats the area here. When it heats the area here, then atomic migration happen and well done between these two plates. We call it is the friction stir welding. Friction stir welding. So you can see that it is well done by friction also as well. So this is also another case of solid state welding. More cases in solid state welding, we call it is the ultrasonic welding. Ultrasonic welding here, we apply ultrasonic. This is ultrasonic. It's like vibration. It's a vibrating this kind of two part here. We would like to weld these two parts. This one is stationary. This one we vibrate like this. Like this, then friction happen in a weld zone. This is a weld zone. We're using ultrasonic. It's kind of high frequency signal we apply, so it is it vibrate this one. When this one vibrate very fast, ultrasonic can vibrate this one with 20 kilohertz, means that it 20,000 cycle per 1 second. It means that when go like here and come back and go again, then it's one cycle. It can make 20,000 cycle per 1 second. So it's very fast, rubbing the surface. These two surfaces will rub together quickly, then temperature increase. Then we can weld these two parts together, as you can see here, or as we show you in the video. So temperature must be below melting temperature, usually zero point 0.5 to zero point 0.7 melting temperature, zero point 0.5 to zero point 0.7, and no filler material. We not added filler material. There are no any filler material here. Just only apply friction and limited to lap joint. This kind of ultrasonic welding limited to lap joint, as you can see here. This one usually used for aluminum and copper, mainly used for aluminum and copper welding process, right? This method is not limited to similar material, but can weld also dissimilar. Remember, all time remember, solid state welding can weld also this similar material, not only similar, but also this similar material. Right. This is ultrasonic welding application. Welding actually dominating industry, whether it is solid state welding or liquid state welding, dominating industry for wide range of applications. This is some example of application you can see here, but actually there are many and many and many more application in industry. Automated in a welding. Automated in a welding, actually welding is could be manually. This is the machine welding. This I believe most of you know this machine. It's manual machine. This is portable machine, can be used in a factory, can be used in a field. So this is a portable machine, but the problem with this kind of welding process, it is manual. I mean, it is different from weld to weld. It depends on the experience and skill of the person who do the welding process, the operator. So usually you can see that welding is not equal and not even if you try to do same welding for several welding part or for mass production. So another process is the automated weld. Automated, we put the weld weld gun or weld tool on a machine, so it can do the weld automatically without the interference of the human. This one help to make weld is the weld quality, improve the weld quality, improving the weld process, improving the weld quality, and reduce the weld time. The weld time become shorter and become very fast, and also eliminate the human factor in a welding process. We call automated welding. Another process is robotic weld. Robotic weld is also being used in a mass production actually. In a mass production, automatic welding like robotic weld is being used in a mass production, as you can see. This to help for mass production. Otherwise, you cannot just do manual welding for mass production. Let me show you this nice video about the robotic welding process. Right? You see that this is a company, a car company. This is a big weld. It is very fast, as you can see. This is for mass production. Otherwise, if you try to make it manual, it take very, very long time. But here you see, it's a very fast process. And robot here is handling the welding process. You see how many robots being used here in the company? So several weld done simultaneously actually. In assembly, it's kind of assembling car parts and also assembling car chassis and assembling the car body also as well. So you can see very quickly then comes and you see welding done. This welding, this provide very good quality welding. Not only that, but also provide equal weld. So robot doing welding for every car. How many car be produced? Maybe 100, maybe more than for a month. Then you can see that welding done equally for all car, all same, because here done by using robot. So this is very good, excellent, and quality is also very good, this one. And also shortening the time because this is mass production. Then you see very short time, everything done, and you get the next step and so on. So it is perfect way actually, it is perfect way to do the welding process. Okay, get back again to the slides. Right, so this is dominating in the car industry actually. The automated weld or robotic arm weld is dominating the car, especially for car manufacturing. This one dominating actually. Weld joint. Now we're going to talk about the weld joint. Weld joint, there are some different type of the weld joint being used based on what? Based on what? Based on the Welding International Welding Association. The Welding Association describes the type of the joint and the type of the weld. There are two issues: type of the joint and type of the weld to fill this joint. And now we're going to describe what is a recommendation, not anything. You must follow the recommendation. I mean, the people who do the welding must follow the recommendation in a welding process. The welding joint could be either whatever we call is a butt joint. This is the one. Okay, this is whatever we call is a butt joint. This is a corner joint. This is a lap joint. This is a T joint. This is the edge joint. So this is a different type of joint based on the welding association. So weld association describes the weld joint you have to do in case if you would like to do the welding process. If you would like to do welding process, you must what? You must prepare the weld joint in this way, either butt joint, either corner joint, either lap joint, or T or edge joint. And then you do the welding for this joint based on that. This one help weld to be good quality and also facilitates the weld process. This is whatever weld joint itself. And now we're going to talk about the weld type to weld this kind of joint. So weld type could be fillet weld, could be groove weld, could be plug and slot weld, could be spot weld and seam weld, could be flange weld and surface weld. Let me show you one by one. Let me show you one by one. First, the fillet weld. Fillet weld. Fillet weld is like triangle. This is a fillet weld. Actually, this is a 3D view of the fillet weld. It's like triangle and well done here, as you can see here. So this whatever we call is a fillet weld. This one can be used with this fillet weld can be used with a corner, lap, and T. This is a corner. This is a corner, lap, this is a lap, this is a T. So in case of corner, lap, and T, usually we use fillet weld. So fillet weld is a right triangle. We use the fillet weld which is looks like right triangle with the corner, lap, and T. Usually this fillet weld done by arc or oxfoil gas welding. Arc welding and oxfoil gas welding being used to create this kind of fillet weld. This is the first type of the weld. Second type is whatever we call groove weld, and they call it groove weld because here we create groove initially. Before we do the welding, we create groove. We create groove and then we do the welding in the groove. So they call it groove weld. And the groove weld could be either square or bevel. This one is bevel. This one is bevel. This one is V because it is like looks like V. This one is U. This one is J. Actually, this one, the other one, the last one is a double V. Double V. The last one, this one is double V. Double V. V up and V down. Then this is square. This is bevel. Bevel like here. This is bevel shape. This is a V shape. This is a U shape. This is a J. J is two side, maybe J in this side or the J. This is double V. This is a 3D view of this one. And then you put the weld here. So initially you create the groove with this shape and then you do the weld in the groove. You do the weld in the groove. And this mainly associated with the butt joint. Associated with the butt joint. Only butt joint. They call it is a groove weld. Right. Second or next is a plug weld and slot weld. Plug weld and slot weld is you would like to weld these two parts together. Someone said that fillet weld is fine. You put fillet weld here and here, and you put fillet weld here and here. Yeah, it is okay, but for some technical reason, maybe for some technical reason, we cannot do fillet weld here and here. So not allowed to add it weld here and here for certain technical reason. Then in this case, they create hole here up, only up. They create hole and put the weld here and here. They call it plug weld. This one slot weld. Instead, like this, they make not hole, but they make slot. And then they put the weld in the slot. Then weld will attach those parts together. And this one mainly to not added whatever we call is a fillet weld up and down. Then plug weld or slot weld can solve this issue, right? Next is this is a flange weld. This is a surface weld. Flange weld is this is kind of, you can see this is a type of the joint, and here in this type of joint, then we added the weld here. We call it is a flange weld. This is a surface weld. Actually, in the surface weld is not welding, but we call it like surface weld. But however, this one we're not welding parts together. This one we depositing material only in the surface, probably to compensate some wear happen or something. So we put some material on surface. They call it surface weld. Actually, this case, only this case, in the surface weld case, there are no welding. There are no welding actually. It's only used to not used to join. It is one part actually. But the main issue here, we deposit material here, like to compensate somewhere happen or something you need to recover, then you put some material on the surface. That's it. Next is spot weld and seam weld. Actually, this is really important. This is really important. This one we call it is a spot weld and seam weld. Spot mean you do the welding in certain spot. You do the welding in certain spot, certain area. So you can see that this is a spot welding spot. You do the weld in this spot. This is the electrode, upper electrode, and this is the lower electrode, and this kind of electrode are electrical conductive material. Workpiece also must be electrical conductive material. You pass electricity here, you connect the power here, then current will pass through from up to down. Weld will happen here in this area between the two parts here. Weld will happen here between the two parts where highest resistance located. This one we call is the resistance welding also as well. We call it spot welding or resistance welding as well. So weld happen, just please give me your attention. Weld happen here in between. If you like to weld these two plates, then weld not, will happen between here and here, where the spot area, exactly at this spot area will happen here, and then you can repeat here, and then repeat here, and repeat here. Every area depend on where you fix the spot, right? Why it happened like this? Actually, we call this one is resistance welding. What happened if you magnify this area? If you magnify this area, what you can see this is a material one, this is a material two. This is a surface between or the interface of the layer one, the surface material one or surface of material two. You can see that current, actually you push big amount of current, you push big amount of current. This is big amount of current, you push big amount, very big amount of current from up to down. So current would like to move. You can see that big amount of current, big amount, very big amount of current. You push big amount of current here, very big amount of current, high amount of current, and this current would like to move from up to down. What will happen? Current cannot pass from up to down except only few points, which is a contact point between surface 1 and surface 2. Then you see that only few contact point here. Then current have to, then you get here traffic jam. You get traffic jam. All current have to pass through only few points. Then what? This whatever we call resistance. You get traffic jam here. Very crowded. This area become very crowded with the current. All current, then you get loss in energy. This is kind of energy loss. Electrical energy loss become heat. Then temperature increase exactly here in this area. Big electrical energy loss you will have it happen here exactly in this area between the two parts where the highest. So why that's why we call resistance welding. So this is the highest resistance area. Then because of the loss of energy, then electrical energy converting to heat, then temperature increase as you can see here, then material will be melted, and then you get well done here. Where exactly in this location, in this spot. exactly in this spot. What about other places? Maybe here, not affected actually. The only spot, this is only the spot, right? Only the welding happened in exactly in this spot. So that's why they call it is a spot welding, which is a part of resistance welding. Any question? Yeah, Muhammad. Muhammad, yes.
دكتور, why the lower plate is displaced؟ ليش هذا اللي تحت مزاح شوية اليمين؟
لا دي بس فوتو يعني، مش اكتر يعني، مش
لا
مشكلة
لا
طبعا.
اللي تحت
ايوه
شفت
هنا
ليش
بتكلم.
مو اثنين على نفس المستوى؟
يعني هما الاثنين على نفس المستوى، هو بس عايز يوريك شكل الايدج هنا. لا doesn't mean anything.
اه
يعني there
اوكي.
are no meaning يعني هم قد بعض يعني. هو just to show you يعني it's kind of outline no meaning يعني. يعني هم قد بعض، اعتبر ان هم قد بعض يعني just to show you no issue. Yeah. Any
اوكي.
question guys? Yeah. Any question? Okay, that's it. So this is the spot welding. I hope and this is the resistance welding and this spot welding, and welding done exactly here in this area, right? Another resistance area we call it seam welding. So we have spot welding, seam welding. This one seam meaning line. The word seam meaning line. So welding happened in a line. And the seam welding here we remove the electrode, the spot, and we put roller, rotating roller, and also connect with the electricity. Then this roller is rotating while this material will feed. Then you get several spots. You get one spot, another spot, another spot, another spot, another spot. So actually, this kind of seam welding, it is multiple spot welding, but they connected together. It looks like a line, become like a line where exactly in between up and down, exactly in the middle here, where highest resistance area located, right? Then you get whatever we call seam. Someone said that what is the interval depend on off. If you make on off mean you get big interval, but get on off. I mean quickly you do this one, you get probably continuous line. So line here will be depend on the frequency of the electricity you apply. On off then he give you big interval or small interval of the spot based on the frequency of the current that you apply to this one, right? So we call it is a seam welding. It is exactly like spot welding, but continuous spot welding, then you get a line instead of spot, then you get line, right? Next is we're going to talk about the physics of the welding. Actually, this one need your attention. So physics of the weld. So we say that well done as based on high density heat energy. Whatever we call high density heat energy. What is that mean? High density heat energy or high heat density? What is the high heat? Not high temperature. He didn't say high temperature, but he said high heat density. Let me explain what is a power density or heat density. Let me explain what is the power density or what is the heat density. Please give me your attention, guys. Um, sun, you know sun اللي هي الشمس، يعني الشمس كلنا بنمشي في الشمس مفيش أي مشكلة. If you bring a focus lens, this is the sun. If you bring a focus lens and this is a paper, and then you use a focus lens, what will happen? You can burn the paper. The paper in ordinary case no issue. Paper in the sun يعني لو حطيت البيبر الورقة، لو جبت ورقة في الشمس مفيش أي مشكلة، تمام. ولكن if you get a focus lens, here, then what will happen? You can burn the paper by using the focus lens. Why? What happened actually? This what happening, this is a focus lens, this is a sun ray, this is a sun ray coming, and this is a focus lens. Then sun ray actually focusing all energy, this is big amount of energy, but distributed on a big area. This big amount of energy distributed big area. When you put a focus lens will focus all this energy in very small area. this one will burn the paper. Okay, then power density, what is the power density? Equal to the power divided by area. You can see that the power is same. We didn't change the power. Sun is same. الشمس هي يا شباب. احنا ما غيرناش الباور، يعني قيمة الباور هنا ما اتغيرتش. قيمة الباور ما اتغيرتش. احنا كل اللي عملناه ايه؟ جمعنا الباور دي في حتة صغيرة جدا جدا جدا، السطح المعرض دي، يعني كمية باور كبيرة جدا حطيناها في اريا صغيرة جدا، فبقت الباور على الاريا we call it is the power density. This what we looking for, not power but power density, because here if you put the paper here, if you bring the paper, this is a paper, right? If you put the paper here, what will happen? If you put the paper here, what will happen? Nothing. If you put the paper here, nothing will happen. Why? Why nothing will happen? Because the energy power is same. يعني الباور، يعني انت لو حطيت الباور هنا، البيبر دي اتعرضت لنفس الباور، يعني البيبر دي متعرضه الباور هنا بي، والبيبر دي متعرضه الباور هنا برضه بي. So power same actually. The power here is B, power here, all heat here. ما هو الباور هي هيت ريت. الباور هنا احنا بنقول عليها هيت ريت. الوات هي جول بير سكند. Please give your attention here the important power هنا اللي هي جول بير سكند. Let me just write power هنا equal ايه يا شباب؟ جول بير سكند. فالباور هنا هي جول بير سكند، الباور جول بير سكند، جول اللي هي الهيت، الباور هنا جول بير سكند، يعني احنا بنسميها اللي هي الوات. الجول بير سكند يعني وات، يعني equal to جول بير سكند، يعني equal to ايه؟ equal to watt. الوات يا شباب اللي هو الوات اللي هي الباور equal to جول بير سكند. فلو انت بصيت للبيبر هنا، البيبر هنا متعرضه ايه؟ للباور دي. الباور دي هي احنا ما غيرناش الباور. same power which is the sun coming from sun. ماشي؟ يبقى الباور دي متعرضه، البيبر حصل لها حاجه هنا؟ nothing. مش هيحصل للبيبر اي شيء. لكن البيبر هنا يحصل لها ايه؟ الورقه هنا لو حطينا الورقه هنا يحصل لها ايه؟ تتحرق. يعني احنا الورقه هنا حطيناها تتحرق، لكن الورقه هنا لو حطيناها مش هيجرى لها اي حاجه. ايه الفرق بين هنا وهنا؟ الفرق هنا ان الباور دي كانت distributed among big area، لكن هنا الباور هنا distributed among very very small area. That what we call is the power density. That what we call power density. So power density equal to power divided by area. So let me just say again, emphasize again, we are not looking in a welding, we are not looking for power or heat, but we are looking for power density or heat density. Power density or heat density. Any question guys? حد عنده اي سؤال؟ واضح مفهوم الكلام اللي انا بقوله؟ Okay, so power, always power is the heat rate. When said power, which is a watt equal to joule per second. Watt equal to joule per second. I'm saying again because we're going to use this one many time coming. So please remember, what is the heat rate, which is a joule per second. You divide by the area, or joule, you can just say joule per area, or joule per second, which is a watt per area. This is a power density or heat density. Right. So this is what we're looking for actually. Let's apply in a welding. In a welding, we can use gas welding. This is a gas welding. This is a gas welding. Gas welding as an example. This is a torch. Can you see that? And this is a flame. This is a gas welding. One way we can use a gas welding. Gas welding create a high heat actually, big amount of heat. Big amount of heat you can see, but distributed among big area. Distributed among big area. This is a gas. So you see that this is a heat, big amount of heat, but distributed among big area. So this is a big area. So what is the power density here? You can see that when you use a gas welding, usually the power density not very high. Yeah, welding will not very high, not very high. Compared with what? Compared with other type of welding like arc welding. In arc welding, the area here is smaller. In the laser welding, area is very, 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 very small compared with this one even. In the laser welding, the area here in a micro scale. The area here in a micro scale. Right, area in a laser welding is a micro scale. Area here is in fraction of millimeter. area for example, this one in a millimeter scale. In a millimeter scale, you can see this one maybe 2 millimeter, or in a millimeter scale. So you can see the big area here, this big area. Here, fraction, here a small area actually, but still for laser is a very, very, very small area compared with this one. And you can see that. You can see that this one is a laser welding, for example, or electron beam welding, laser or electron beam welding. This is gas welding. This is arc welding. Arc welding. This is a gas welding. You see that gas welding is very big area. The gas welding here area is very big. You see, compared with the laser, laser here focus in very, 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 very narrow, and that's why it is deep, because the heat density is very high. Heat density here in a laser or electron beam, because it is focused in very, very small area, is in the power density or heat density is very high. Then you can see that it is narrow and very deep. Narrow, 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 yeah, small and deep. That's why that if you would like to make a deep hole, you need to have high power density, not power density or heat density, not heat, not temperature. For example, if I say that to make a deep hole, you have to have a higher temperature. No, not high temperature, but high what? Heat density, power density. Right? You understand me? So this is what we would like to say. So focus, it is narrow but deep because the power density is very high. Here you can see electrical arc welding. Electrical arc welding, you can see that bigger area, bigger area. Even this is flame welding. It's even bigger. We have here whatever we call it is a heat affected zone. Heat affected zone, not melted actually. This area will be melted. This area is melted and well done here. But this area not melted. But the structure of this area is changed because of the heat. So we call it heat affected zone. It is affected but not melted. You can see that this heat affected zone area is very small here, here bigger, here very big. And this heat affected zone is not desired actually, is not desired because it is destroys the mechanical properties and destroys the microstructure properties of the material. So if I ask you, I would like to do the welding process with the lowest possible heat affected zone. What is the process? It mean high power density process is suitable for producing is narrow and deep and smallest heat affected zone. Right, so this whatever we call is the heat affected zone. You can see that power density in flame welding, this is the gas welding, is 10 watt per millimeter square, joule per second. This one joule per second. It is 10 watt per millimeter square. Arc welding, then you get 50 watt per millimeter square. Better, higher power. I mean, arc welding higher power density than gas welding. Gas welding is the lowest, actually, the lowest power density is a gas welding. Arc welding is 50. Resistance welding, that we spot welding and seam welding that we described in a previous 3 or 4 slides. Then resistance welding make 1000 watt per millimeter square. Laser welding 9000. You see that? Because you see that area here in the laser area is very, very small. It's micro scale area. You get 9000 watt compared with gas welding and arc welding. This one is huge. That's why, because the power density is very high, it can produce very deep welding compared with gas welding and arc welding. Electron beam is very similar to laser welding. We call it electron beam. This one very similar to laser. It is also micro scale and even sometimes nanoscale welding is 10,000 watt per millimeter square. So you can see that, you can realize that how this the difference between welding type. How, what is the difference between, I mean the difference in the power density between welding type, right? Then power density, we can conclude that power density, time to melt the material, is inversely proportional with the power density. Higher power density, lower time to melt the material. You agree with me? Higher power density means that it is inversely proportional. Higher power density, lower time you can. Then fast, very fast. Whenever you have a higher power density welding type, then quickly you melt the material, quickly, well done. Lower density, if the power density is too low, is if the power density is very low, then heat will the heat uh, will not be able. If it's very low, then the heat will not enough to melt the material. Just heating the material, for example, can be used for heat treatment something, but probably will not be able to melt the material. If power density is very high, it may evaporate the material. It may evaporate the material. If the power density very high, then it may evaporate the material. If evaporate material, welding also not happen, because evaporating material, we're losing material actually. We need to just melt. We need to only melt the material. We need liquid mix. We need liquid mix. Then you get a weld done. If you evaporate this liquid, then weld will not done. Then we don't want to have a very high power. Then there are a practical range between very high and very low where weld can be done. Then we have to compromise power density, not very high, not very low, something in between, so weld can be done easily and without any problem. Okay, there are an example. There are an example. Heat source transfer 3000 watt. This is the heat source. Transfer 3000 watt. We said that watt is a joule per second. Watt is a joule per second to the surface of metal part. This is the surface of the metal part. The heat impacts the surface as a circle area. The heat here impacting the surface at the circle area. The heat distributed here in a circle area, as you can see, with intense vary inside the circle. Intense of the heat vary inside the circle. The distribution is as follow. 70% of the heat transmitted within circle of 5 millimeter diameter. This circle is 5 millimeter diameter. Can you see that this circle is 5 millimeter diameter? Uh, 5 millimeter diameter. This circle is, this white color circle is 5 millimeter diameter. He said that 70% of the heat transmitted in this 5 millimeter. Why he said like this? 70% of the heat transmitted in this white color circle with 5 millimeter diameter, right? And 90% is transmitted within a circle of 12 millimeter. If you increase the diameter to 12 millimeter, if you increase the diameter to 12 millimeter, then you get 90% is, this one is 70%. 70% of the heat transmitted in 5 millimeter diameter. But if you increase diameter to 12 millimeter, you get 90% of the heat transmitted. Probably if you increase the diameter more, 100% will heat will transmitted in a bigger area, because here, as I told you, this is a flame. This is a gas welding. Gas welding usually distributed among big area. So 5 millimeter, 70%. 12 millimeter is 90%. Probably if you increase the radius bit, maybe 100 millimeter, probably 10 centimeter. I mean, 100 millimeter, 10 centimeter, within 10 centimeter, probably this kind of heat distributed in 10 centimeter, probably something like this. What is the power transmitted? What is the power density in 5 millimeter diameter? The question is, what is the power density in 5 millimeter diameter? What is the power density in 90 millimeter diameter? What is the power density in the ring between 70 and between 5 and 9, between 5 and 12 millimeter diameter? Let's take one by one. First, what is the power density in 5 millimeter diameter? Power is 3000 watt. He said like this, the power transmitted is 3000 watt. He said that we have to carefully understand 70% transmitted here and 90% of the power transmitted here. So he said 70% of the 3000 transmitted in 5 millimeter diameter. So 70%, you can see that 70% transmitted, 70% transmitted here, 70%. So 70% is transmitted in a white color area, which is 5 millimeters. This is the area. This is a 5 millimeter area. So 70%, which is this one, transmitted in 5 millimeter area. Right. Then the power density transmitted in 5 millimeter equal to 2100, which is 70% of the power, divided by the area, which is 5 millimeter diameter area. Then you get this is a power density. So this is a power density. This is the first question. Power density. This is a power density in 5 transmitted in 5 millimeter area. Right? If I ask you what is the power density transmitted in 90 millimeter area, okay, then you get the area 90 millimeter area. This is a 90 millimeter area or 9 centimeter area. You get the area, and the power here 90%. This is 12. Sorry. If I ask you what is the power density transmitted in 12 millimeter area, then this one will be 12 millimeters. Then you get the area of 12 millimeter, and then 90%. You multiply 90%, you get the amount of the power. You get the power density in 12 millimeter area. But he don't ask this. He asks what is the power transmitted in the ring, which is the blue color. In the ring, which is a blue color between 5 and 12. This is a ring. Then the power transmitted in the ring is between 70 and 90, mean only 20%, 20% power transmitted in the ring. The area of the ring is different between 12 and 5. This is the area of the ring. And the power is 90% minus 70%, which is 600, only 600 watt. 600 watt only transmitted in the ring. Then you get the power density 600 divided by the area of the ring. Then you get the power transmitted in the area of the ring here. Area of the ring, which is a blue color ring. Right, so this is about the power density. I will stop here. Next time I'll talk about the heat balance in vision welding. This is because time is just finished. Yeah, I will stop first. I will stop